Welcome back. This is the second lesson recording for IM2, March 1st, 2021. So let's summarize some of the key observations from the three different methods. What are the advantages? What are the disadvantages of each method? For the quadratic formula, it can be used for solving any quadratic equation. So that's definite pro, okay? It's for any quadratic equations. However, the con is that it is cumbersome, it takes time to substitute, and there are more calculations. That means you're more likely to make little errors here. And when you do make errors, because you're just substituting values, you're not necessarily going to be able to see that you made an error. Whereas with other methods, you can quickly check by squaring or square rooting or whatever that you will be able to see it. Zero product, it is straightforward when equations are already in factored form or if they are easy to factor. Okay, so that is going to be the fastest way to solve quadratic equation is by factoring, if it can be factored or if it is easily factorable. However, it cannot be used if it's not factorable, or if the numbers are really big, the coefficient, or if you're talking about decimals or fractions or whatever else, then it would not be the one to use. Square rooting is also straightforward when equation is in the vertex form. However, it cannot be used if not in vertex form. So that means, but for now, because we have not learned how to convert standard form to vertex form yet, for now we can only use it if there are no bx, the middle term, present. Okay, so otherwise you need to convert it to vertex form. So with that, you're going to be working on card number 9 to 12 of Desmos. Card number 9 is a card sort, where you are grouping the different equations with the different solving method. Alright, so when I have 3x squared is equal to 27, I know that I can divide both sides by 3, and I'm going to be left with something squared is equal to 9. So that means I can solve this by square rooting. So I am going to move my method right there and move that here. Alright, this is also something squared is equal to another constant, so that means I can use the square rooting method. Let me move things about so that I am going to be able to see all the equations. Okay, alright, so then, oops, I don't want you grouped. Alright, so then here is another equation that is something squared minus 5 is equal to 0. This is in vertex form, or I can very easily no, this is in vertex form, so I can put it there. I have these equations. Alright, I have an equation that is already factored and that is equal to 0. That means I can use zero product property and factor. Alright, then I have these equations. So for this, you need to first see, are they factorable? These three equations, all the leading coefficient is 1. That means I'm thinking x squared, are they factorable? How do I do that? I am going to convert it to standard form. So x squared plus 5x plus 4 is equal to 0. Okay, so is this factorable? Yes, it's going to become x plus 1, x plus 4, because 4 times 1 is positive 4, and 4 plus 1 is 5. So I'm going to use that by factoring and zero product property. X squared minus 2x minus 3 is equal to 0. Okay, so negative 3 and 1, positive 1 would add to negative 2. So this is easily factorable, so I'm going to go with that. What about x squared plus 6x plus 1 is equal to 0? Is this equation factorable? No, it is not factorable, so that means it's going to be over here. 2x squared minus 10 is equal to negative 30. Okay, so then I would like to quickly look to see. Okay, the numbers are, the leading coefficient is small, so they are factorable. So let's see which will be easier. Oh no, it's 2x squared is equal to 40. 2x squared is equal to 40. So this is actually solved by square rooting. That will be easiest. And then 5x, so here you have 2x, so if I subtract 9, okay, so it's 11x squared minus 9x minus 18. Okay, so yes, this is maybe factorable, may not be, but we're dealing with big numbers, so I am going to go with quadratic formula. And likewise with this, yes, I can factor this. Try to, let's see, 5 and then 1 and 7. Actually, this is not factorable. So that means it has to be solved by quadratic formula. So I have 13 cards correct so far. Great. Alright, so what is the solution to the equation x minus 1 all squared is equal to 25? Sketch your work below. So let's do that. Okay, so what do? X minus 1 all squared is equal to 25. So that means I need to take a square root of both sides. That will be the easiest way. And take a plus or minus, and that leaves me with x minus 1 is equal to the square root and the square, they cancel each other out, is equal to plus or minus, what's square root of 25? That's just 1. So that means I have two versions, x minus 1 is equal to 5, or x minus 1 is equal to negative 5. Okay, so and then add 1 to both sides, and I get x is equal to 6, and add 1 to the other side, and I get x is equal to negative 4. Notice that it's not 6 and negative 4. Okay, the numbers are quite different. Another problem, x minus 1 all squared is equal to 0. Okay, so let's try to solve this. X minus 1 all squared is equal to 0. So that means we are going to take a square root of both sides again. When I do that, I'm going to put plus or minus. That leaves me with x minus 1. Okay, oops, I don't need that, do I? I don't need the parentheses because it has just been cancelled out. The square root and square cancels out is equal to plus or minus, what's square root of 0? It's actually just 0. That means you have x minus 1 is equal to 0, and x minus 1 is equal to negative 0, but there is no such a thing as positive and negative. So the only solution you have is when you bring 1 to the other side, x is equal to 1. So you actually only have one solution. What about this problem? X minus 1 all squared is negative 25. So x minus 1 all squared is equal to negative 25. Again, we are going to take a square root of both sides. Don't forget the plus and minus when you do that. Okay, so on the left hand side you're left with x minus 1 because square root and square cancels it out. The right hand side, square root of negative 25. Can you have a square root of negative number? Remember a few weeks ago, or we've already talked about this, you cannot have two numbers that multiply to negative 25. Okay, because 5 times 5 is positive 25, and negative 5 times negative 5 is also going to be positive 25. There is no way you can get a number that multiplies to itself twice to that get you a negative number as your final product. That means there is no solution. So there is no solution. We can't go any further. That means there are no x values that will satisfy this equation. Okay, no solution, or I could even say no real number solution. Because later on we are going to find that there is no real solution. However, we can find complex number solutions. So let's summarize our findings from Desmos. We just looked at the three different equations. X minus 1 all squared is equal to 25, or x minus 1 all squared is equal to 0, and x minus 1 all squared is equal to negative 25. What did we find? We found that with x minus 1 all squared is equal to 25, we found two different solutions. X could be equal to 6, or x could be equal to negative 4. With x minus 1 all squared is equal to 0, we found that you would have one solution, because square root of 0 is just 0. There is no positive and negative version of 0, so the only solution is x is equal to 1. Whereas the last problem, we found that there is no solution, because we got to this plus or minus square root of negative 25, and we can't have square root of a negative number, so there are no real number solutions, so we can say there are no solutions. Later on you're going to find that we can, if we open it up to complex number, then we can have some solution, but for now there are no solutions. So with quadratic equations, solving quadratic equations, you can have two solutions, one solutions, or no solution. With that, you're going to go on to Desmos card number 13 to 17. Card number 13. Decide how many solutions you expect to have this equation to have. We take a square root of both sides. The right hand side becomes plus or minus 7. So that means we have two different versions of an answer. It's going to be two solutions. What about this? We divide both sides by 2. Then you take a square root, and you're going to take a square root of negative 2. We can't have a square root of a negative number. That means that's going to be no solution. 15. Decide how many solutions you expect. Take a square root of both sides. What do you have? Square root of 0 is just going to be 0. There will not be a positive and negative version. That means you're just going to be left with one solution. And then 16, decide. Okay, so in this case, what do we need to do? We need to bring the 6 to the other side. So it becomes 5x minus 2 all squared is going to be equal to negative 6. Square root of negative 6. You can't have a square root of negative 6. So again, there will be no solution. And in this case, x plus 11 all squared plus 6 is equal to 6. If I subtract 6 from both sides, I am going to be left with x plus 11 all squared is equal to 0. When I take a square root of both sides, I am going to be left with one solution, because square root of 0 is 0. So you're just going to be left with x plus 11 is going to be equal to 0. So x is equal to negative 11 are the solutions. I am going to end the recording here, and I'm going to continue with application problems in the next recording.